Okay, hello everyone. Welcome to Unitronics webinar number 5. This is a continuation on data tables and data logging. If I can just get a quick response from a couple people. Can everyone hear me okay? Is the audio okay? And can you see my desktop all right? Yes? AV okay. Great. Thank you, Jeff. Okay, so this is data tables and data logging part 2. If anyone listened last week, remember that we created a application to do some data logging. Oops, I'm sorry. We picked a memory bit, a memory integer, and a memory long to record to our data table. We also recorded the date and the time for each of these loggings. We went over what the data table editor does and how to set one up. We created some example information with some system bits. So we introduced some system bits, system bit 13 specifically. Let me scroll down to it. The rising edge of the 1 second pulse to increment some example data every second. We talked a little bit about timers and creating a timer function to do our data logging. So if you remember again, we every 1 second we're recording the date and the time and the 3 pieces of information to the data table. We talked about strings briefly, and we went over our real-time clock to ASCII functions. Again, RTC is real-time clock. So we use these to save the current date and the current time to strings that we log to our data table. We also went over the idea of the row index. Oops, I'm sorry, I'm opening the wrong one. The row index that we used for the data table write row. This is how we indicated what row to write to. And then we changed our approach and created the system we have here, which instead of going from row 0 to 99 and looping around, is doing a FIFO. So we shift the next piece of information to the top of the data table. We have this up online. If anyone hasn't seen it yet, maybe the first one's a good place to start. Don't disconnect, though. You can see it afterwards as well. This week, we'll be looking at what to do with this information. Now we have it in data table. We'll be using our data export software, which is a free utility, which is available on our download page at unitronics.com, and then support, and then downloads. We're going to use it to pull the data table off and store it as an Excel file on the computer. And we'll be looking at how to do this on a time-based schedule automatically, or on an event-driven command from the PLC. We're also going to look a little bit at TCP/IP connections, because we need to, for the second option, use TCP/IP. So let's take a quick look at the data table in the PLC and just see what's going on currently. Again, we should be able to see our shift register example from last week. If we look every second, the new piece of information is coming down, and it's stored at the top, and it shifts all the information down, and when we get down to our last row, 99, it just gets pushed out. Okay, so let's look at data export and how to download this data table to the PC. You notice that there is some new code here. We don't have to look at it yet. We'll discuss it later on. So I'm going to minimize this, and I'm going to open up data export. And I've just created a folder with a shortcut here. That's all I've done. Okay, that's that error saying I've moved a file. That's okay, because we're going to create a new one anyway. So let me just go to new. Okay, so welcome to data export. This is again the utility we have for downloading data tables off the PLC onto the PC. The first thing we need to do when we use data export is under design. Under design, select PC ports. We have to add our communication port we wish to use. For this first example, we're going to do this all over serial. So just like we do with VisiLogic, we're going to use our serial connection. So by default, these settings are fine. Notice we have modem support as well. We're not going to worry about that right now. We're just going to hit OK. And notice that our COM1 has now been added to this list. Okay. Oh, I should mention also, by the way, Jason Lettieri is also here to answer questions. He's listening. If you have a question at any time, please feel free to type it and send it, and hopefully Jason can give you an answer. If we want to save major questions for the end, we'll have a little bit of time to review and go over any topic we covered or anything that might be related if you have a question. So do feel free to ask questions. Also, try and think of applications where you can use these things. A lot of times it's nice to have an idea, and then if you have a question on how to apply it, you can let us know and we can help you out with that. But to continue, we've added our PC port. We're now going to add a site. And this is the specific instance of data export that's going to communicate to our controller. So let's go ahead and we'll give a PLC name test. We have to specify a couple things now. We are using a Vision controller. I should mention again that this is the V570 from last week we're using. We have a couple nice options in data export. One is this memory bit to set. One nice thing is that after we've performed a connection and we've done all the tasks we've specified, we can set a bit. We can use this as an indication, say, we have successfully connected and downloaded information from the controller. Once we set this bit, we can use it to maybe initialize the controller and maybe clear out the data table in the controller or the memory regions that we're logging to. We can also select Synchronize RTC, and this will update the time in the PLC every time we connect to it. So in order to keep maybe all of our PLCs we have out in the field synchronized at the same time, we can use this option. I'm going to go ahead and underneath PC port, I'm going to select our COM1 that we specified. We can use our network communication options too over CAN bus or RS-485. In this case, we're going to leave it as direct connection. We are going to create an Excel file. Notice we also have the option to create a CSV. One thing that's nice is we can use a template. So if we have a predefined macro or a script in an Excel file, we can load that and we can run our new data through our macro, which is in the template. And we can also shift the position that the information goes into. So instead of starting always in 1-1, meaning A and row 1, we can shift it down to maybe C and 5 if we have some header information or column names. This is a nice option to have. And again, it's going to pertain specifically to the Excel file that you're using, but it's a nice option. We're going to leave it alone at 1-1. So we notice on the right we have schedules, tables, regions, and emails. We have to define some of these items in order to save and use our project. So the first thing we'll take a look at is schedules here. Notice we open up a specific schedules menu. I'm going to go ahead and click Add New. We'll call this description test. Now we can define a start time that we want our event to happen on, and we can define a reoccurrence. So if I say we want to start today the 19th, and I want it to happen every, let's use a logical example, every 8 hours. Maybe we have an 8-hour production run and we have 3 going in a day, and we want to download the total part count every 8 hours, so the end of a shift. If we use this schedule without an end, we will download the data table to our computer as an Excel file every 8 hours. You can see how this could be useful. Of course, if you have different data tables and different information you're logging, you're going to have to tailor this to, of course, your situation. One thing I'd like to point out again is the data table that we can write to is 120K. So if we have a data table that's going to fill up in 5 hours, this is not a good example in that case or solution. So part of this is also going to be tailored by the project that we've built. And again, one of the considerations we need to have before we even start working with the data table is how much data do we wish to log and for how long. For this example, I don't want to wait, so I'm going to select an absurdly large value of days for the repetition. We're going to see that we can also do a manual force call. So I'm going to hit OK, and we'll see that we've defined one schedule name, it's test. Maybe we'd give it a better name in real life. The time units is every 575 days. The start time is 11:13 today, and we have no end time. So I'll hit close this. Of course, we can add more or remove or duplicate, but we have defined one schedule. Now we're going to add our table. Go ahead and double click on tables. See again the similar menu. We're going to click add. Now we have again the data table in all of our vision controllers. One thing we didn't mention last week was there's also a database of 1,024 memory integers or registers that we have set aside for the M90. We can use this to download those too. But we won't worry about that right now. The first thing we need to do is import our data table structure. So we'll go ahead and click here. We're going to give it a name. We'll use again test. We can read from the PLC, or we can use a UPD file. Again, I'll show you in VisLogic from the data tables. We can create these files here. Export to file. So we don't necessarily have to have connection or communication to the controller to set up a data export file, but we do need to have, of course, the data table structure. And again, when we define the data table in the editor, it's really the structure we're defining. Whether it has information in it or not is another question, but the structure is what's important. It's what tells us where to pull out this specific information or this cell in a large amount of memory. So we're going to go ahead and click Read from PLC. We are connected over serial here. Notice it loads. Data table structure name, test. Great. We'll come down to data table structure, and we'll click on it. We've loaded our table in. Again, table 1 is the name that we've given our data table. Table 1. If we had more than one table, we can select that from the list. Okay. And now some options we have. Read the entire table. We're going to read the entire table. We want to read the whole thing in and save the whole thing as an Excel file. But we can also read to and from specific cells, which is a nice option. Also a very nice option is the ability to set a specific memory bit based on reading just the table. So notice that we had the option to set a bit earlier in the general site. This will tell us if the entire communication session has been completed, and the specific bit for the table will tell us if we've downloaded this specific table. And this is a very nice option because this will allow us to have a scheme where we can be satisfied that, or we'll be knowledgeable we've actually downloaded this table from the PLC. We can use that to erase the data table. And then we can continue to record. Again, 120K is a good amount of information as far as text and integers is concerned, but it can fill up, especially if we're recording large strings and we have a short frequency in which, or rather I should say high frequency, in the time that we're recording new items to the data table. Okay, but we'll leave these options for now. We'll hit OK. And again, notice our table is here. Read from and read to, we're not going to worry about because we didn't define anything. So I'm going to hit close. Now regions is also a nice option. Again, we're going to hit add. We can, I'll give it the name test. We're not actually going to define this, but we can read any of our operand types. So we'll just select memory integer. And we can read a block of memory integers. So if I say from 10 to 20, when we connect, we'll also download a block of memory integers, memory integer 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Are there any questions so far? Or is everyone following?